All right. Unit 5, lesson 18 is going to be on standard normal distribution. So you did a little bit of normal distribution in Algebra 2. And basically, the idea is you have an average, typically a mean is what we'll refer to when we're doing normal distribution. We're going to be using means that when you look at something like height, like we have here, let's say the average height somewhere is 5 feet 9 inches. As you go further and further away in either direction, so you go 5'10", 5'11", 5 or 6 foot, or if you go down 5'8", 5'7", 5'6", less and less people will have that height. So, if this right here in the middle, I know it says 52 here, but if this were 5 feet 9 inches, then there would be slightly less people that would be 5'8" and 5'10". There'd be even less people then that would be 5'7" and 5'11", and so on until you get to, like, 6 footers and people who are 4 feet tall. It goes down and down and down. That's a normal distribution. So in a normal distribution, we're going to be dealing with a certain mean and then a standard deviation. And if you remember from previous chapters, standard deviation is how far apart things are spread. So what'll happen is if you have two distributions where the means are different, but the standard deviations are the same, your curves are going to look exactly the same, except the middle of your graph is going to be in a different spot. Whereas if you have two means that are the same and the standard deviation is different, and the one where the standard deviation is bigger, the stuff's going to be spread out further. So you're going to have this kind of longer, flatter graph than you would if you have a smaller standard deviation. So pieces of your distribution that will be true is your curve will be bell-shaped. If it's truly a normal distribution, and most things in life aren't exactly normal distribution, they're close, but if it's a true normal distribution, the mean, median, mode should be equal, and it should be in the middle of your graph. This is the big one here for us. Total area under a curve is going to be 100%. And then, again, if it's truly normal, one standard deviation should have approximately 68% of the information from the center. Two standard deviations, 95% of the information will be within that, and then 99.7% will be within three standard deviations. So the moral of this story is as you get further and further away, it's less likely to happen. So almost all of your numbers will be within three standard deviations. So it's unusual to have something that's 5 standard deviations or 9 standard deviations away from the mean. Just because almost everything needs to be in this area right here. What we're going to deal with in this section is a standard normal distribution, where anytime you see the word standard in there, it'll typically be underlined like on a test. It means you're going to have a mean of 0 and a standard deviation of 1. Back when you didn't have calculators, you had to normalize things by making it a mean of 0 and a standard deviation of 1, but because we have a calculator, which is what I'm going to show you here next, you don't use a lot of this, but there are a couple instances where it's used. So again, know that the area under the curve is 100%. All right, or if we're writing it as a decimal as well. So this is the spot we're going to use in the calculator here, normal CDF. I'm going to show you that in an example. And sometimes we're going to go to infinity or negative infinity, which those buttons are not on your calculator. So when we do those, we're going to use a very large number if it's positive infinity, or a very small number if it's negative infinity. And I'll show you how to put those in your calculator as well. All right, so when you go to take the test, you're going to need to draw these curves for each time you do a problem. I think in the homework it's probably drawn in there for you, and then you just fill it in, but if it's not, then you're going to draw it. All right, find the area under the normal curve between z-score of 0 and 2.34. All right, so draw a curve. So mean here of 0. And we are going between, you're always going to draw your mean in the middle here. So for all these problems in today's lesson, it'll always be a 0. So we're going to go from 0 to 2.34. So 2.34 is a positive number that would make it to the right of that. And we are looking for this area right here. Okay, the mean right here, this line here in the middle would make the graph 50% on the right and 50% on the left. So we know we're going to get an answer that's less than 50%. Question is how less. So we are going to do normal CDF from 0 to 2.34 with a mean of 0 and a standard deviation of 1. So that's the order that you do these things in here. You do the lower bound, the upper bound, the mean, and the standard deviation, which was spelled out right here on the previous page. Okay, so on your calculator, you go to second and vars, and then we're going to be doing normal CDF. We're not going to do normal PDF. That's a different thing, and if you take another statistics class, you'll learn what that is in there. Then it'll give you this here. So for ours, we had a lower bound of 0 and upper bound of 2.34, mean of 0 and a standard deviation of 1. Paste that in, and we get that for an answer. So if we're going to go, let's go 3 decimal places, and then, so that'll be 0.490, which if we write that as a percent, 49.0%. All right, same idea here. Find the area between 0 and negative 1.75. So normal CDF, negative 1.75, 0, mean of 0, standard deviation of 1. And just repeat the process on your calculator here. Second vars 2, so negative 1.75, 0, 0, 1. 0.460 around that, so 46.0%. All right, just a couple of little differences that you can come, because each one of these problems will be the same idea. Area to the right of 1.11. Okay, so I want that right there. So in this case, we're going from 1.11 to infinity. These graphs, I know I kind of hit the x-axis there, I really shouldn't. Kind of goes like that. It keeps going forever and ever and ever. So you're going to do normal CDF, 1.11, infinity, 0, and 1. Okay, now like I said, there is no infinity button on your calculator. So 1.11. So we need for our upper bound some really large number. So you could just, give it a bunch of 9s if you want to. That's perfectly fine. Or right above the comma, there's this double E button, which when you hit second and the comma, it's just going to put a single E there. I'm not sure why it does that, but and then I'm going to type in a 99. What that would be is a 1 followed by 99 zeros. Obviously a large number. Okay, so 13.3%. All right, again, just some notation. I have a z-score less than 1.65. Everything here. So now I'm doing more than half the graph. So I should get an answer that's bigger than 50%. All right, so this one's going to be, since we're going all the way to the left, this will be negative infinity, 1.65, 0, and 1. All right, so this time I'm going to do negative E99 and 1.65, 0, and 1, 95.1%. All right, and then the 0 to 2.32 is going to be similar to this one right here. Except it's 2.32 instead of 2.34. That was the last one, or the first one, I should say. CDF 0, 2, 3, 2, 1. So as you see, it's kind of the same thing over and over again. It's just making sure that you put the numbers in the right spots. So 49.0%, same as it was on that first one there. See, it was a slightly different answer, but when you round it, it gives you that. All right, and the last one for this stuff, I want to the right of 2.43 and to the left, negative 3.01. So there's one of two ways that you could do this. You could do each one of those individually and then add them together. Or you could do in between those two and subtract from 100%. Remember, this whole entire thing is 100%. So instead of doing this twice, you could do 1 minus normal CDF in between the two. Either way is going to give you the same answer. So again, you could do to the right of 2.43, get an answer. Do to the left of negative 3.101, get an answer. Add the two answers together. Or you could do it this way. 1 minus normal CDF of negative 3.01, 2.4301. All right, so a really small number. 0.9% for that one. Okay, and the last thing is, what if we go in reverse? What if I give you the percentage? You have to give me the corresponding scores. Okay, so that is going to be on the calculator, inverse norm. So what we're going to do, even though the calculator has some capabilities of changing this around, you see more people mess this up. So just to be consistent, what we're going to always do is area to the left of what we're looking for, then the mean and standard deviation. So here's what I mean before I actually do them. So if I'm looking for this score right here, and this is 21%, that is 21% to the left. This one I'm going to be able to just type straight into the calculator. What if I gave you this one down here? That one's to the right. Well, if the whole thing is 100%, then if this is 73% here, this would be 27%. So when I go to put it in the calculator, I'm going to put the 27 in, not the 73. Because me saying 27 to the left or 73 to the right, it's still the same spot. Okay. So this one here, there's 42% to the left, but stopping here. Now remember, this stuff here is 50%. So I would put those two together to go from here all the way over. So the trick is I went from the line all the way over. The line all the way over. Okay, then I'll talk about this one here. I'll do that one last. All right, so this one, inverse norm, 0.2101. Okay, same spot in the calculator, second bars, except now we're going to do the third one for inverse norm. So my area was 0.21. Mean and standard deviation were 0 and 1. Now here's where you can change these things, but again, I'm going to ask you not to. We're going to always just do left, paste it. Okay, so we get, let's go 2 decimal places with our z-scores, so unless directions tell you differently. So negative 0.81. Now, negative 0.81. This is not a percentage. This is a score. So when you do inverse norm, let's write that up here. Not a percentage. It's a score. You just found the z-score is what you just did. Okay, whereas when you're doing this stuff here and you're finding the area or the probabilities, those are percentages. So normal CDF, right, as a percentage, inverse norm, You do not, because it's just the score. All right, on this one, inverse norm. Okay, so from this line all the way to the left would be this 42 and this 50, so it would be 92. So 0.920. Oops. Okay, 1.41. And what you'll notice is that when you have numbers that are less than 50% with a mean of 0, your numbers are going to be negative, which should make sense because it's to the left of 0. And when it's bigger than that, you should get a number that's positive. All right, so this one here is going to be, since it's to the left of 0, I should get a negative answer. So inverse norm, oops, learn how to spell, 2701. All right, that's a 1 at the end there. So negative 0.62. Okay, so on this one, I want to find two scores. So if this is 62%, that leaves 38% left. And if these are even, we're going to assume that these are evenly spaced. This is the middle 62%. So half of 38 would be 19. So that means there would be 19% right here. Another 19% here. Okay. So from this line to the left would be 0.19. So I would do inverse norm, 0.190. From this line to the left, it would be these two put together. So it'd be inverse norm point. So 62 and 19 added together is 81. So 0.81, 0, and 1. Now, when you do those, 0.19, you get negative 0.88 for an answer. When you do it for the other one, oops, negative there. You get positive 0.88. So because the mean is 0 and these are going to be evenly spaced, if this is negative, then that one will be positive. Okay, so on this one, because I'm asking for two of them, you're going to get two scores. All right, that is standard normal distribution. If you know how to do this stuff, that is, everything else in the chapter is pretty much a continuation of that. All right, let me know if you got any questions.